These are every Boeing innovation that changed aviation explained, starting with the 707. Before the late 1950s, air travel was glamorous but painfully slow. Propeller planes rattled across the skies, taking over half a day to cross the Atlantic, often stopping to refuel. Tickets were outrageously expensive, meaning only the wealthy few could enjoy the privilege of flight. Aviation was stuck in a luxurious but limited era. Then Boeing dropped a bombshell, the 707, the jetliner that ignited the jet age. Derived from the company's experimental -80 prototype, the 707 wasn't just faster, it was in another universe. Cruising at nearly 600 miles per hour, it slashed New York to Paris trips down to 7 hours. Suddenly, crossing oceans felt less like an expedition and more like a simple trip. When Pan Am introduced the 707 in 1958, it wasn't just an aircraft, it was a symbol. Its swept back wings and powerful turbojets screamed modernity. Ordinary travelers who once thought flying was a dream could now book a seat. Airlines raced to order fleets of them, reshaping global routes almost overnight. The 707 didn't just change flight times, it changed culture. It made the world smaller, gave birth to true international tourism, and turned air travel into something accessible instead of untouchable. The jet age had officially begun, and if the 707 set the world on fire, the 747 was about to throw gasoline on the flames. The 707 may have launched the jet age, but it also created a new problem. Demand exploded. Airports were suddenly overwhelmed, ticket sales surged, and airlines were desperate for bigger aircraft. Boeing's answer? Build something so massive, so unprecedented, that it would forever change what the word airliner even meant. Enter the Boeing 747, the world's first wide-body jumbo jet. When it rolled out in 1969, people could hardly believe their eyes. This machine was nearly twice the size of the 707, capable of carrying more than 400 passengers and featuring a range that spanned continents. But what truly made it iconic was that strange bump on top, the upper deck hump. Many assumed it was just for luxury lounges, but in reality it was born out of practicality. Boeing originally thought the 747 might one day be replaced by supersonic jets, so they designed the nose to swing open for cargo. The hump allowed the cockpit to be placed above, preserving that option. Yet instead of fading into history, the 747 became the queen of the skies. Suddenly, intercontinental flights weren't just for the wealthy elite. Ordinary families could afford trips to Europe, Asia, even Australia. Mass tourism was born at 35,000 feet. The world seemed smaller, more connected, more accessible than ever before. The 747 wasn't just an aircraft. It was a cultural icon, a technological marvel, and a revolution with wings. But Boeing wasn't done. Next, it would transform not the size of the plane, but the very cockpit itself. By the late 1970s, Boeing faced a new frontier. Airplanes had become bigger and faster, but inside the cockpit, things still looked like something from World War II. Rows of analog gauges, spinning dials, and flickering needles covered every inch of the flight deck. Pilots had to constantly scan dozens of instruments just to stay ahead of the plane. It worked, but it was exhausting and dangerous if something was missed. Then came Boeing's next revolution, the glass cockpit. With the introduction of the Boeing 757 and 767 in the early 1980s, the company replaced most of those mechanical dials with digital displays. Suddenly, flight information could be integrated, simplified, and visualized in real time. Pilots no longer had to hunt across the panel. They could glance at crisp screens that told the full story of the aircraft. This wasn't just a cosmetic upgrade. It made flying safer, more efficient, and far less stressful for crews. Situational awareness improved dramatically, and airlines quickly realized that fewer crew members were needed in the cockpit, reducing costs. For passengers, it meant smoother flights, fewer delays, and a level of reliability the propeller age could never dream of. The 757 and 767 didn't grab headlines the way the 747 did. But make no mistake, they marked a technological leap just as significant. This was already a huge step forward for aviation technology. But next up, you'll see how what Boeing unveiled with the 777 took things to an entirely new level. It wasn't just progress, it was mind-blowing. When Boeing unveiled the 777 in the mid-1990s, it wasn't just a new airplane. It was a declaration that the future had arrived. Nicknamed the 777, this aircraft wasn't designed on drafting paper. It was the first Boeing jet created entirely on computers, a radical step at the time. But the most mind-blowing change wasn't how it was designed, it was how it was flown. The 777 became Boeing's first aircraft to fully embrace fly-by-wire technology. Instead of relying on a maze of cables and pulleys connecting the cockpit to the wings and tail, the pilot's commands were now translated into digital signals. Those signals were sent to computers, which then moved the control surfaces with pinpoint precision. Why did this matter? Because it made flying both safer and smarter. The computer systems added protections that prevented pilots from pushing the jet beyond safe limits, reducing the risk of catastrophic mistakes. At the same time, the 777's flight deck was cleaner, more efficient, and far less physically demanding to fly. Pilots loved its responsiveness, airlines loved its efficiency, and passengers loved the comfort of an aircraft built for ultra-long-haul travel. The 777 quickly became a superstar of the skies, earning a reputation as one of the most reliable and beloved jets ever built. But Boeing wasn't done. If the 777 reimagined the way an aircraft was controlled, the next leap would reimagine the very material it was made from. Get ready, the Dreamliner is coming. By the 2000s, airlines wanted more than just bigger planes. They wanted smarter planes. Rising fuel prices and growing environmental pressure forced manufacturers to rethink everything about efficiency. Boeing's answer was the 787 Dreamliner, and it wasn't just another jet. It was a technological reset. For the first time in commercial aviation history, about 50% of a major airliner structure was built from carbon fiber composites, a material lighter than aluminum, but incredibly strong. This bold choice instantly made the Dreamliner lighter, quieter, and dramatically more fuel efficient than anything before it. But the benefits didn't stop there. The 787's composite structure allowed for higher cabin humidity and lower cabin altitude, making long-haul flights noticeably more comfortable for passengers. The advanced aerodynamics, serrated engine nacelles, and quieter operations also made the Dreamliner one of the most eco-friendly jets in the sky. Airlines flocked to it not just for its efficiency, but for the new routes it unlocked. Suddenly, thinner, long-haul city pairs like Boston to Tokyo or London to Austin became possible without massive wide bodies like the 747. The Dreamliner shrank the world even further, but this time with sustainability at its core. The 787 redefined what a modern airliner could be. But next up, you'll see how Boeing and General Electric tackled something even more jaw-dropping. Engines so massive, their fans were nearly the size of a Boeing 737's fuselage. If the 787 changed what airplanes were made of, Boeing's next revolution changed what powered them. Enter the GE90, the largest and most powerful turbofan engine ever to fly. When it first roared to life on the Boeing 777 in the 1990s, it stunned the aviation world. The GA90-115B variant could generate an earth-shaking 115,000 pounds of thrust, enough to lift a fully loaded twin jet across oceans with ease. But it wasn't just power, it was efficiency. With a record-breaking bypass ratio, advanced composite fan blades, and cutting-edge materials, the GE90 allowed airlines to replace 4 engine jumbos with 2 engine 777 cellishing fuel costs while extending range. This engine alone reshaped global air travel economics. And just when people thought engines couldn't get any bigger, Boeing unveiled the 777X, powered by the next-generation GE9X. Its fan is so massive, over 11 feet in diameter, that you could literally fit the fuselage of a Boeing 737 inside it. With ceramic matrix composites and higher efficiency than its predecessor, the GE9X makes ultra-long-haul routes like Dubai to Los Angeles more practical than ever before. Engines this colossal don't just push airplanes, they push the limits of imagination. And together with Boeing's daring innovations, they've redefined what's possible in the skies. Now it's your turn. Which of Boeing's groundbreaking innovations do you think changed aviation the most, and what do you believe might come next?